I'm making this video just because for tomorrow I don't want to spend too much time having to review things. So I'm making a video for you guys to go talk about some things we talked about yesterday to make sure that we are still on the same page. Some people seem to get it. Some people seem to be a little bit confused still. A couple of things I want to talk about is that when you're taking two square roots, it doesn't matter what the numbers are. So A and B represent any number you want. Pick a number. So if you say square root of 9 times the square root of 2, there's two ways I can do this problem. One way is because they're both square roots, it's like variables. When you multiply variables, the only time you can actually add the exponents is if they're the same variable. Same thing happens with square roots. When I multiply two radicals, which is, the symbol, they have to be the same root. So, we have square roots, we have cube roots, we have fourth roots, so on and so forth. But anyways, when I'm multiplying two square roots, I can multiply these two numbers and get the square root of 18. But if we're simplifying it, square root of 9 times square root of 2, well, we know what the square root of 9 is. It's 3 times the square root of 2. Because this is the whole number, this is a square root. When I multiply them, my final answer is simply just 3 square root of 2. You kind of want to treat the square root as a variable. I can't take 3, if I have 3 times a variable, my answer is just 3 and that variable. Nothing happens. So I can't take 3 times the square root of 2. If I do, I'm going to get a decimal, which we're not doing that right now. That's why we're just simplifying it as an answer like this. So, we did this problem yesterday. 3 square root of 5. 3 over the square root of 5. Now, this is rationalizing the denominator because I cannot have a square root underneath my fraction bar or in my denominator. I'm going to go ahead and also do this problem right here. Square root of 9 times the square root of 5. Just bear with me. Square root of 9 times the square root of 5 is 3 square root of 5. Why? Because the square root of 9 is 3. 3 times the square root is just 3 square root of 5. Or, if you want to, put that dot there. You don't need it, though. 3 square root of 5. Well, keep that one in mind. So up here, I want to get rid of the square root of 5 in my denominator, so I take the square root of 5 times itself. Why? Because in the end, anything times itself is, well, the number that's underneath. The reason being is because the square root of 5 times the square root of 5 is the square root of 25, which the square root of 25 is just 5. This is kind of doing this rule is kind of skipping this middle portion and going straight to the answer. But the square root of 5 times the square root of 5 is just the square root of 25, which is 5. But when I go to do 3 times the square root of 5, again, it's a whole number times a square root. Again, this is like a variable. When I take 3 times a variable, it's just 3 and then that variable. So this one is just 3 times the square root of 5. Which is the same thing we got when I took the square root of 9 times the square root of 5. The square root of 9 became 3 times the square root of 5, which just gives us that. We're doing the exact same thing. Wow. We're doing the exact same thing. The only thing we added really was this step. This is the new step. This right here is nothing new. That's what we did when we were simplifying square roots. This step is old. This one's the new one. And I know some people were having trouble in understanding this step right here. So then, for example, these are the problems I wanted you guys to do. I'm going to go ahead and give these answers. So, I got to times it by the square root of 3. The square root of 3 times the square root of 3 it becomes the square root of 9, which in the end is just 3. 2 times the square root of 3, well, is 2 square root of 3. Again, it's 2 times the square root. I can't actually take 2 times the square root of 3 because I will actually get a decimal. I can show you, look. 2 times the square root. If I, it might help to turn this on. So 2 times the square root of 3. Right? If I multiply that, guess what? Well, this calculator tells me it's 2 square root of 3 because that's what it should be. Or I get a decimal. Same thing if I were to take the square root of 2 times the square root of 3. This is a different... This is a totally different problem. It's 2 square roots when I multiply it. When I take 2 square roots and multiply them, my answer is just, what's 2 times 3? It is 6, but it's the square root of 6. So this is my final answer for number 2. Number 3. I got to multiply the top and bottom by the square root of 7. Anything times 1 is itself. Unless you mean, do you want to write, if you want to write the 1, sure, fine. You don't need it. Over 7. That's our final answer. I don't like having the 1 in front of it because it's not necessary. So I prefer my answers to look like this one. Number 7. You have this 1 over the square root of 81. This is actually an easier problem because if you look at that problem, you know what the square root of 81 is. The square root of 81 is 9. So my final answer is actually 1 over 9. Number 8, multiply the top and bottom by the square root of 11. The square root of 11 times the square root of 11 is technically the square root of 121, which is 11, with the 2 square root 11 on top. Again, hopefully these are making more sense, but again, if they're not, please make sure you ask questions. Once you get the hang of these problems really don't take that long. 1 times the square root of 3, again, is just the square root of 3. Over 3. Again, when you have a problem like this, you can't reduce these. So I should have mentioned that in number 2 as well. The square root of 3 over 3 cannot be reduced. Again, you treat that like a variable. So if I had, for example, if I had x over 3, I can't take x over 3 because, I just can't do that. It's the same thing as the square root of 3 over 3. If I were to do that on my calculator, the square root of 3 divided by 3, look what it gives me, the square root of 3 over 3. And then number 11, 1 over the square root of 225. When you have big numbers like 81 and 225, ask yourself first, can I reduce that square root? Or even better, is it a perfect square? Luckily, I gave you a list of the first 15 perfect squares. So if you look at that list, you will know that the square root of 225 is 15. And that is your final answer. Again, if you have questions about these, please let me know tomorrow. Because tomorrow we're going to do the ones that this one that I didn't do yesterday. And then we're going to go over these 4, which we haven't done yet. So, which is 4, 5, 6, 9, and 12. So please watch this video if you have any questions, especially if you're still confused. But I will see you guys tomorrow. Have a great rest of your day.